Hello everyone, welcome back to my channel. I hope you guys are doing good. So before going ahead, if you are interested and want to learn about the electrical vehicle, battery management system, working of EV charging and the powertrain system or the automotive technology, then you are in the right place. So welcome back to my channel. My name is Amit and I have been working in the automotive industry for last 6 years as a hill commissioning engineer in the EV powertrain domain. So in my day-to-day work, I test and validate system like the battery management system, BMS in short, EV charging system, powertrain controllers and other vehicle controller unit. So before they are used in real vehicles. Okay. So on this channel, I will explain this topic in simple way. I will try to make all those topic as well as simple as okay. So I will explain this topic in very simple way, as much as simple I can. I will try to explain it. So using both industry experience and is a real life example, I will try to teach you. So you don't need to be a engineer, okay, or the experience background to understand this concept. So here we don't just learn the theory, we understand how this system work in real vehicle and how they are tested in the automotive industry. Okay. I will combine practical industry experience and simple explanation. So these concepts are easy to understand. Okay. So everything I will explain in is based on my hands-on experience working in EV automotive industry. So I will try to make those things easy and simple to you. So let's start today's topic. Let's get started. So in previous video we learned something very important, right? Why can an EV battery store only the DC current, not the AC current? So in last session we concluded our previous session with a question, right? How exactly the AC current from the power grid is converted into the DC to charge the battery, correct? So in today's session we are going to answer this bigger question that come to the almost every people who on the electrical vehicle, right? So if our home supply only AC and EV battery expect only DC, right? Then how does an electrical vehicle charge? Think about, right? It is the point of to think, right? So usually every night thousands of EV owner plug their car into AC wall socket, but somehow the battery inside the car receive only DC. So where does this conversion happen? This is the our question, right? Is it happening inside the car, inside the charger, or somewhere else? So by the end of this video, you will know exactly how it works, right? If you already know the answer, you can comment your answer in comment section. I will happy to read those answers. Okay. Okay. So let's look at this slide carefully where I left last time. So this slide is called the fundamental mismatch, and believe me, this single picture explain one of the bigger question in the engineering challenge in every electrical vehicle, right? So answering this question, you can see in slide left side, sorry, we have our electrical grid from where power is coming in form of AC, right? This is the same electricity that come into our home, right? You agree, right? On the right side, at the right portion, we have an EV battery. This is the EV battery pack you can see here in the PPT. And in this middle, we have a big question mark, that is the conversion challenge. So this question marks tell how and why and where this thing is happen, because these two system speak completely different language. Two system means your our the AC power that is coming from the grid and the DC power, right? These both are differently completely different. So let me ask you something, like if I give you a simple example. So imagine you have two friends and one is speaking only English. Suppose that, right? One friend is here, one friend is right side, and other speak only Japanese. So can they communicate directly? Probably not, right? They need a translator. Something happened here in between both of them. We need a translator, right? To understand what the first friend is saying to the second one, right? Here we need translator to translate one language to for other one to make it understand. So going ahead, and today video is about the that translator itself. So before we talk about this the solution, let's first understand the problem. So can anyone tell me what does AC actually means? If you know the answer, please comment your answer in comment section. If you already know the answer, otherwise I am here to tell you. Okay. So you can write your answer in the comment in the below. Okay, so moving ahead, let me explain it. So AC stand for the alternating current. That simple means electricity keep changing direction very frequently. So better real life example, if I talk, imagine two people trying to push a car. One person push it forward, the second person immediately push it backward, then forward, then backward. So this cycle is uh, continuously going again and again. What do you think? Will the car move? Not really, right? That exactly how AC behave. The current keep reversing its direction very quickly, very frequent way, right? So now here is the interesting part. This direction does not change once or every minute or every second. It's changed 50 times every second, right? 50 times in every second. That's why our electrical supply is called 15 hertz. That is the main reason. Pretty amazing, right? Is it? So now let's come to the battery. You can see here we have a battery pack. So regarding this, I have another question. Question is, why can't batteries simply accept the AC current? Why we need to convert it in DC? So if you know the answer, please comment. Okay. Meanwhile, I'm moving ahead. So after all, electricity is electricity, right? So if I tell you a real life example, think about filling a water bottle with a tap. So water flow from the top tap into the bottle, right? And the bottle fill up. It's simple. It's very simple, right? Now imagine every second the water start flowing backward, then forward, and then backward again. If it's repeat this cycle, do you think the bottle will even fill? Of course not, right? That's exactly what would happen inside the battery if we supplied AC directly. It will not charge, and it could be possible it damage the battery. So now we have a challenge, right? This is the big challenge. The power grid give us AC, the battery need DC. They cannot work together directly. So question is, who convert AC into DC? That's the exactly what, this is the big question, right? So in the next video I am going to show you will you I am going to show you that the first electronic component that start this entire conversion process. And trust me, once you understand this electronics power component is working, understanding the EV charging system became much easier for you. Trust me. So before moving to the next video or next session, let's quickly revise what we learned in today's session. So first point is our home supply AC and EV battery need DC. Because of this mismatch, AC must to be converted into DC, and that exactly we are going to be learn in next video. So before we move on, I have a question for you. Where do you think this AC to DC conversion actually happened? Inside the vehicle, inside the charging its station, or in both? Type your answer in the comment. At end of this video, we will see you our right place. Okay. So in my day-to-day work as an hill engineer, we validate charging system before they are used in actual vehicle. Understanding this AC to DC conversion, what is this conversion is. So not just a theory, it's something automotive engineer work with during development and testing, verification and validation, right? Okay, so that's all for today's session. Today we will learn why battery cannot store AC and why every electrical vehicle battery need DC for charging. I hope this explanation made the concept simple and easy to you. In the next video, we will learn how AC convert into DC using the bridge rectifier and the all power electronics component, and I will explain it step by step with a simple animation and real automotive examples. Okay. So before you go, I would like to love to hear from you what topic you like me to explain in next. Not in next actually. So this lecture, this session, all upcoming session regarding the AC DC charging, EV charging system working, and the protocols. Okay. So let me know in the comment below. I read your comment and they help me to decide what video to make next. So if you found this video useful, please hit the like button. It really helps the channel channel reach to more people who want to learn EV technology. And if you don't want to miss upcoming videos on the electrical vehicle battery management system, EV charging, powertrain system, and the automotive engineering, make sure to subscribe to the channel and press the bell icon so you will be notified whenever I upload the new videos. Okay. Thank you so much for the watching. Until next time, keep learning, keep growing, and let explored the world of the automotive engineering together. Okay guys, see you in the next video. Take care, bye bye.
Absolute most fascinating engineering hurdles in the entire world of green energy. If you've ever looked at the massive transition to electric vehicles and kind of wondered about the hidden complexities going on behind the scenes, well, you are in the right place. We're going to unpack the core architecture of EV charging, and it all comes down to a fundamental mismatch in how energy is moved versus how it is kept. Okay, let's dive into this. It seems like a super simple proposition, right? You've got an electric car and you have electricity literally running through the wires right outside your house. So why can't you just plug that EV battery directly into the power grid and fill it up like a water balloon? It's a great question, and it instantly sets up the core puzzle of modern charging infrastructure. Because there is a very real physical reason why this direct connection is completely impossible. Let's start with part 1, the power grid and alternating current. So think about the massive power grid that distributes electricity across our cities, countries, and continents. The whole thing relies on alternating current, or AC. Picture this electricity traveling down from utility poles as a continuous oscillating blue waveform. It's moving back and forth, pulsing in this synchronized rhythm that lets energy travel vast distances super efficiently. This blue sine wave, it's basically the powerful dynamic heartbeat of our entire electrical infrastructure. Which brings us to part 2. The conversion challenge. But as that dynamic oscillating blue electricity travels from the grid right toward your driveway, it hits a dramatic roadblock at the vehicle. Now, the physical reality is that an EV battery simply cannot accept grid AC power as is. It is physically impossible to pipe that alternating waveform straight into a battery cell. The energy literally hits a wall, creating this massive gap between what the grid provides and what the vehicle actually needs to function. Moving on to part 3, EV batteries in direct current. Because inside the EV battery itself, the energy behaves entirely differently. Unlike those undulating blue waves of the grid, your battery requires a straight, stable flow of orange energy to enter the individual cells. This is direct current, or DC. EV batteries can only chemically store direct current. There's no pulsing oscillation here, just a smooth, one-way flow of power. And fun fact, trying to push AC into a DC battery without converting it wouldn't just fail to charge it, it could catastrophically damage the chemical cells. Total disaster. And this brilliantly illustrates the fundamental mismatch we're talking about. Look at them side by side. On one side you have AC, an oscillating, moving waveform designed for transmission. And on the other side, you've got DC, a straight, stable flow designed for storage. You literally cannot fit a wavy, alternating peg into a straight, direct hole. The energy language of the grid is just fundamentally incompatible with the energy language of the battery. So when we zoom out and look at this entire journey in one complete picture, from the utility pole distributing AC, through that glowing conversion gap, and finally into the battery pack storing DC, the core takeaway is crystal clear. The central challenge of all EV charging infrastructure isn't just generating the power, it's figuring out exactly where and how this crucial conversion from AC to DC takes place. Every single time a car is charged, that conversion has to happen somewhere, whether that's in a small converter built inside the car itself, or in a massive high-speed converter built into the charging station on the side of the road. Ultimately, the whole shebang boils down to this single, undeniable fact. Batteries store DC, not AC. As we transition millions of vehicles to electric power, this fundamental mismatch isn't going away. Every single EV requires this conversion, which leaves us with a pretty massive question for the future of our infrastructure. If every single EV needs this heavy-duty conversion, how will the physical placement of these massive AC to DC converters reshape the layout, the architecture, and the electrical demands of our future cities and highways? It's definitely something to think about the next time you see a charging station. Thanks for joining me on this explainer, and keep asking the big questions.